Weather monitoring stations throughout Vermont have recorded atmospheric disturbances centered on the Bennington Triangle that reflect broader climate change impacts affecting the region. The National Weather Service began noticing changes in their automated weather stations in 2020. But the patterns have intensified as Vermont experiences the effects of a warming climate documented in the National Climate Assessment. Vermont's Climate and Health Profile report shows that the state's winters have warmed faster than any other season, with average winter temperatures rising by 4 degrees Fahrenheit since 1960. This warming trend has shortened freeze seasons throughout the state, but the effects appear more pronounced within the triangle boundaries. Temperature monitoring within the area shows variations that exceed regional warming patterns, creating localized conditions that differ from surrounding areas experiencing similar elevation and terrain characteristics. The shortened freeze seasons have altered precipitation patterns throughout the triangle in ways that exceed statewide trends. Vermont has experienced a 21% increase in heavy precipitation events since 1958, but the triangle receives significantly more rainfall than regional climate models predict for areas with similar topography. The excess precipitation has exposed structures and pathways in the forest that were previously hidden under soil and vegetation layers. These newly revealed features include stone formations that don't match the geological composition of the surrounding area. The exposed structures show evidence of deliberate construction rather than natural formation, with some appearing to be foundation remnants from structures that don't appear in any historical records. The stones themselves are composed of materials that geological analysis shows originated from locations hundreds of miles away, indicating they were transported to the triangle rather than quarried locally. Earlier ice-off dates on Vermont's lakes, as documented in lake ice phenology studies, reflect warming trends that are affecting subsurface conditions throughout the triangle. Ground temperature monitoring shows that subsurface temperatures are rising at rates that exceed regional warming trends. These temperature changes are occurring in patterns that correspond to the underground geological features discovered in recent surveys, suggesting that climate change may be affecting the stability of natural cave systems and underground water channels. The combination of increased precipitation and warming temperatures has destabilized soil conditions throughout the triangle, creating areas where surface stability can't be guaranteed. Heavy rain events, which have become more frequent and intense throughout Vermont, create conditions where clay layers become extremely slippery and underground water channels experience increased flow rates that can weaken overlying rock structures. Wind patterns within the triangle have become increasingly erratic, validating warnings that the Algonquin people issued centuries ago about the place where the four winds come together. Modern anemometers installed throughout the area record wind speed and direction changes that occur rapidly enough to affect aircraft navigation. Pilots flying over the triangle report sudden wind shear conditions that force them to alter course, even during periods when aviation weather reports show stable conditions. The wind anomalies reflect the complex terrain interactions that occur when changing climate patterns encounter the triangle's mountainous geography. Warming temperatures create different air pressure gradients than historical patterns, leading to wind behaviors that don't match traditional mountain weather effects. These changes create turbulence patterns that extend above the triangle, affecting aircraft at altitudes where local terrain historically didn't influence wind conditions. Climate change has intensified the frequency of extreme weather events throughout Vermont, but the triangle experiences these events with greater intensity than surrounding areas. The region's complex topography appears to amplify the effects of changing weather patterns, creating conditions that can rapidly shift from stable to dangerous. These rapid changes create challenges for hikers and search teams who may encounter weather conditions that differ significantly from regional forecasts. The increased frequency of heavy precipitation events has revealed that the triangle's drainage patterns don't follow typical mountain watershed characteristics. Water flow during intense rain events creates temporary streams and flooding in areas where topographical maps don't indicate water features. These ephemeral water features can create hazardous conditions for hikers who may encounter rushing water in areas they expected to be dry. Wildlife behavior changes within the triangle have accelerated as climate change alters habitat conditions throughout the region. Trail cameras positioned throughout the forest show that normal wildlife activity patterns have been disrupted as animals adapt to changing environmental conditions. Areas that previously supported diverse animal populations now show reduced wildlife presence, creating zones where animal activity is significantly diminished compared to historical patterns. The wildlife behavioral changes correspond to areas where climate change effects appear most pronounced, including zones with altered precipitation patterns and temperature variations that exceed regional norms. Animals appear to be responding to environmental changes that affect their ability to find food, water, and suitable shelter within their traditional habitat ranges. Climate researchers studying the triangle's changing environmental conditions have documented equipment challenges that reflect the area's complex interaction with changing weather patterns. Weather monitoring instruments that function reliably in other Vermont locations sometimes record data anomalies when deployed within the triangle boundaries, particularly during periods of rapid weather changes or extreme precipitation events. The intersection of climate change effects and the triangle's existing geological challenges appears to be creating environmental conditions that increase risks for hikers and complicate search operations. The changing climate is exposing previously hidden terrain features, altering water flow patterns, and creating weather conditions that can change more rapidly than regional forecasts predict. These environmental changes are occurring against the backdrop of the triangle's already challenging terrain and navigation difficulties, creating a situation where traditional outdoor safety protocols may not account for the rapidly changing conditions that climate change is bringing to the region. As these environmental factors continue to evolve, they're creating conditions that may be contributing to increased wildlife behavioral changes and other phenomena that researchers are only beginning to document.